I'm Richard with EV4U. In this video, we will discuss 12 steps to create an off-grid power system. We will also focus on some components used and review some of the basics. So let's get started. Step 1, do your homework. You really should have a big picture understanding before you spend money on any components. EV4U's video series is just one resource for learning about off-grid power systems. Step 2, calculate your loads, both AC and DC. This video series has provided all the information necessary to calculate all of your loads. And remember to add in margin for any future loads. Step 3, determine your battery pack size. Remember, it's less expensive to do it right the first time than to try and correct a mistake later. Your battery pack size needs to handle all of your loads for as long as necessary based on your individual needs. Also, lithium iron phosphate batteries are by far the best value, not only in dollars and cents, but in safety, longevity, and low maintenance. Cost and time and money over the years cannot be beat with any other chemistry at this time. Step 4, plan your load distribution systems, both AC and DC. Make sure you use the correct components, wire, fuses, circuit breakers, etc. Step 5, create a schematic diagram. This is your guide for connecting the system components correctly. Step 6, calculate wire and fuse sizes. Using information from calculating your loads, your schematic, and the location of your loads, you can determine the size of wire to use for each circuit, including the fuse size or circuit breaker. Step 7, recharging your battery pack. Remember to look at the big picture and size your system so that it will keep up with your energy demand. The goal is to have a seamless energy supply, not just like what you have when you're connected to the grid, but better. We did an entire video on this subject. You might want to check it out. Step 8, the transfer switch. This is a very important part of the big picture and protects components and people by making sure electrical energy is where it is supposed to be. The transfer switch ensures that power to your AC circuit panel is from only one source at a time. Guarantee that there's no source able to backfeed to another. Also, remember that power from all sources needs to be switched, whether it's from the battery pack or any other source. That means the solar arrays need to be switched, the battery charger, and all of the AC sources. Fuses are your friend. Use the proper size fuses and circuit breakers on all your circuits. Use GFCIs where it is recommended. Your safety and the safety of others is worth more than the price of a safety device. I also recommend surge protector devices. Step 9, testing. I recommend testing all components and systems individually and systematically. Start from the source, for instance the battery pack. Have all systems turned off and introduce each circuit individually one at a time. I like to test the individual load circuits first and then the charge circuits after that. Also remember to have the power on to the solar charge controllers before applying the power from the solar panels. Step 10, inspection. I highly recommend a thorough inspection of all systems after testing the systems. Be systematic and methodical in order not to miss any issues. Have the power off during the inspection. Check for any loose connections, melted insulation, or any other signs that something's not right. And periodic inspections are also a good idea. Step 11, don't forget to use safety devices. Safety devices like GFCI and surge protectors are cheap insurance and money well spent. GFCI stands for Ground Fault Circuit Interrupter, which is an electrical device that protects people from electric shocks. GFCIs are important in areas where water and electricity can come into contact, like kitchens, bathrooms, and laundry rooms. They can also be used outdoors or in garages where power tools are used. GFCIs can be installed in electrical systems or built into power cords. Portable GFCIs are also available for on-the-spot protection. Surge capacitors act extremely fast and catch those high voltage spikes of an AC line. For the best defense and lightning protection, combine a DC surge arrestor on the array side and a surge arrestor and capacitor on the AC side. Surge protectors should be installed at both ends of any long wire run that is connected to any part of your system, including AC lines from the inverter. Arrestors are made for various voltages for both AC and DC. Be sure to use the appropriate arrestor for your application. Step 12, observation and recording of your energy use and energy creation is recommended. According to the solar charge controller display shown, the solar charger is receiving 1,135 watts from the solar panels, and the voltage from the solar panels is 68 volts. From Joule's law, we know that 16.7 amps is coming from the solar panels. Remember, current is equal to power divided by volts. The solar charge controller is outputting 38.2 amps to the battery pack. The battery pack voltage is 28 28.5 volts, 24 volt system by the way, and is fully charged. The solar charge controller should be discontinuing charging at any moment. The power into the battery pack is 1089 watts. Doing the math, we know that this setup is 96% efficient. According to the battery monitor shown, the battery pack has 324 amp hours available, and the battery pack state of charge is 81%. The battery pack voltage is 13.5 volts, and the battery pack is being charged at 34 amps, and there's 460 watts going into the battery pack. Believe it or not, there can be quite a difference between perceived and actual data. And so it's good to be able to have these readings and to keep track of them so that you know that how your system's actually performing. Not how you think it's performing, but how it's actually performing. And keeping good records can also highlight if there's any issues with your system. Off-grid solar kits are quite popular. I'm not a big fan of kits. I believe you should design and purchase the exact components you need for your unique setup. Let's take a look at this flowchart. The flowchart sums up what we've discussed in this video series. The battery pack provides DC power for all your DC loads, including the inverter. The solar panels and solar charge controller recharge the battery pack. The inverter provides power for the AC load. The transfer switch selects the AC power input to the AC circuit breaker panel. AC power can be from the inverter, the grid, shore power, or a generator. When connected to the grid or a generator, a charger, battery charger, can be used to recharge the battery pack. Now a quick review. First, a couple of formulas. Remember, P is power in watts, E is volts, I is current in amps, and R is resistance in ohms. With that in mind, we're going to take a look at Joule's law again. And Joule's law deals with the relationship between power, volts, and current. Power is equal to volts times current. Volts is equal to power divided by current, and current is equal to power divided by volts. And Ohm's law deals with the relationship between volts, current, and resistance, where voltage is equal to current times resistance, and current is equal to voltage divided by resistance, and resistance is equal to voltage divided by current. Now let's review some common definitions. Remember a coulomb? It's the unit of electric charge. And volt is a unit of potential and electromotive force. Current is the rate of flow of a charge. Amp or ampere is a unit of electric current. Ampere hour, that's just current over time. It's a measure of capacity. Resistance is the opposition to current flow. Watt is a unit of electrical power. Nominal voltage. A battery's nominal voltage is the average voltage it outputs when fully charged. Shunt. We talked about shunts in a recent video. It's used to measure the current flow in a circuit. Series circuit is where the positive of the first battery is connected to the negative of the next battery, and so on. Parallel circuit means that we have a connection from the positive of the first battery to the positive of the next battery, and the negative from the first battery to the negative of the second battery, so on. Battery pack is a group of batteries wired in series and or parallel. Solar panels convert sunlight to electricity. Solar charge controller regulates the voltage and current from solar panels to the battery pack. Remember, there's two types of solar charge controllers, the PWM, pulse width modulation, and MPPT, maximum power point tracking, which is the more efficient of the two, and it provides a much cleaner output that you would want to use with most of your electronic devices today. An inverter inverts DC power to AC power. A converter converts AC power to DC power. And a DC to DC converter is an electronic device that converts a source of direct current from one voltage to another. So say from 48 volts down to 12 volts. And a relay is an electromechanical switch. And going back to the battery packs and talking about series and parallel circuits, you may want to go back and review the video we did on series and parallel circuits so that you're familiar with, the fact that the idiosyncrasies in dealing with volts and capacity and so forth with the different circuits. Like the fact that in a series circuit, your voltages add, but your current stays the same. Where in a parallel circuit, the voltage stays the same, but your current capacity adds, that type of thing. So you may want to review that. Well, let's review a few rules of thumb that we had talked about in previous videos. So to calculate the DC load of the inverter on your battery pack, a 12-volt inverter requires approximately 1 amp of DC input for each 10 watts of AC output. If your energy needs are less than 1,000 watts, then I recommend going for a 12-volt system. If you use between 1,000 and 3,000 watts, then a 24-volt system is better. If you require 3,000 watts or more, then a 48-volt system is recommended. To calculate the size of your solar array, double the amount of daily power used by the battery pack. Well, that's it for this episode. If you have any questions, please leave them in the comments below. In our next video, we will discuss troubleshooting of an off-grid power system. So I hope to see you then. Thanks for watching, and I hope you would like and subscribe.